Hello audience, my name is Freddy Pires. I am a mechanical engineer and I have 3 years of experience designing commercial kitchen equipment. I work for the biggest restaurant chains in the country, uh, and today I'm gonna start doing my own videos showing how to design commercial kitchen equipment on Solid Edge. So my purpose is to show how to use Solid Edge and how to work with sheet metal, specifically building commercial kitchen equipment. And these items have to meet with certain sanitation standards, accessibility codes, UL safety regulations, and and they have to be buildable. So I have to put all this information together and create a design that meets all these requirements. And I'm gonna show you how to do it. I also will be showing you how to use Solid Edge. So this is a two-way tutorial. So I hope you enjoy it. Right now I'm gonna start with something simple, and I'm gonna increase the complexity of the designs over time. And today I'm gonna be building a wall shelf. So here we go. So here's what my customer wants me to design. It is a wall shelf, and it says refer to equipment plan sheet FS Fab 8 for further details and specifications. So here's that detail. It shows a plan view, it shows an elevation, and it shows a section. What I'm doing right now is setting the scale. The scale is 3/4 of an inch is equal to 12 inches. And now I'm gonna proceed and take the measurement of the from the plan view. We can see I'm taking the measurement of the length, which is 2752, and is consistent with what I have in the bottom. And then I'm gonna go ahead and measure how wide it is. It's usually 12 to 14 inches wide. This one is 14 inches. So great. Now I know the size of the shelf, and I'm gonna proceed. And that's on the details specification. That's the edge they want, and the reason they have it at that degree is so it doesn't collect debris. If that angle is at 90 degrees, it will collect food debris, and that's not um, approved according to FSF sanitation standards. Now here you have Solid Edge open. What I'm gonna do is start a new assembly, and as that's a new assembly, and the first thing I want to do is save it. Save it with save it with the item number. So the file is gonna start with a 6, just because it's an assembly. Every assembly starts with a number 6, and then the following 3 digits are the item number, which in this case is 169. And the remaining 3 digits are gonna be 3 zeros, which means it's a top level assembly. Every top level assembly has 3 zeros at the end. Okay, now what I'm gonna do is super important. I'm gonna do in the assembly of file, I will do a sketch that represents the plan view of my wall shelf. So that is the perimeter of the wall shelf. We know it's 14 inches wide by 27 inches long. Perfect. And now I'm gonna go ahead and draw the brackets that is gonna hold this wall shelf to the wall. As one, and as the other one. I'm gonna say that's equal to that, and that is equal to that, because they're gonna be same measurement, of course. This is gonna be 1 inch, and that distance is called to be 2 inches. And then the distance from the edge is 3 inches. Same on the opposite side. Perfect. And that's gonna be my sketch. And I'm gonna call the sketch plane, because it's a plane view. Alright. Now I'm gonna create in place. I'm gonna create the first part, and I'm gonna go to my library, and in the user library, which is all the items that I have in my library, personal library, I'm gonna choose stainless steel number 4 finish, and it's gonna be 18 gauge material. Okay, that's the material I want, and I'm gonna call it, now this is important, 7. Well, I'm gonna choose the right place first, and I'm gonna call it 7, the item number, and 2 zeros, and number 1 is gonna be the first piece, the first part that I create. Here I'm making sure I use ordered technology, not synchronous. I'm gonna start with the tab to make the top of the shelf, the surface. I'm gonna just draw a square and attach every side to my sketch. That is collinear. I'm gonna choose the appear, so I can choose lines that are not in the part, and I'm gonna make all the sides collinear to my sketch perimeter. Great. At this point, that tab is linked to the sketch. So if I change the sketch on the assembly, that tab is gonna change. And now I'm gonna do the counter flange. And doing the profile. That is the profile the customer wants on the shelf, on the front and the sides of the shelf, and so that's what I'm drawing here. I'm on the counter flange feature, drawing that profile. So I'm gonna start with the top corner, drawing a line down and one diagonal to the side, and then I'm gonna put the measurements on it using the distance between feature to put the dimensions on the edge. I'm gonna pick the top and the bottom endpoints, and I'm gonna measure it to 1 3/4 of an inch, and then the diagonal is gonna be 1/4 of an inch. And finally, the angle of the diagonal is gonna be 60 degrees. Perfect. That is the edge we're looking for. We accept it. And that is a profile of the edge on the two sides and the front. And now choosing counter flange, instead of chain we're using edge, so we're gonna pick which edges this profile is gonna be formed at. I'm gonna do the back flange, which is 1 3/4 of an inch, so it is consistent with the edge on the front and the sides. And that's that. Now to get rid of that notch, I'm gonna go to the flange options and then check the box for corner relief. Basically, we don't want a corner relief there, so we choose the feature on the tree, go to options, and then check the box. Okay, finish, and that's it. Perfect. Nice and smooth. And I'm gonna round the edges to a half-inch radius. This is both for safety purposes and also looks better. And it's the way they show it on the elevation, so it's kind of consistent. Beautiful. Now I'm gonna go ahead and do the flat. To do the flat pattern on it, we go to tools and choose a flat pattern and choose the surface and the direction of the grain, and that's it. Perfect. We can close it now. It's already made and it's gonna show on the tree. So we have the first piece ready. We're gonna save it right there, all the work we did so far, and now we're gonna continue with the brackets. Create in place, choose from one of our templates, user templates, and stainless steel for number 4, 16 gauge for the brackets. Okay, and now it's gonna be called, guess what's gonna be called. It's gonna start with a 7 because it's a sheet metal, and the item number and the number 2 because it's the second piece that we create. Just simple. Now go to tools and order and check the order. Technology, not synchronous. I have to change the settings so it doesn't show that way anymore. I want it to be ordered by default. And now I'm gonna start with a counter flange. I'm gonna choose the top surface. The top flange is gonna be attached to the sketch. That's gonna be the side of the bracket. Material thickness towards the inside of the sketch. That measurement is actually 12 inches. Now we do another counter flange on the top and the back so we can attach it to the wall and the top. And this is just a 1-inch flange on the top and the back. There you go. Simple enough. And now I'm gonna choose a counter flange, and instead of chain I'm gonna choose edge to pick the edges I wanna do the flange on. Perfect, that's it, those 2 edges. If I choose chain, it'll go all the way around, so I don't wanna do all the edges. I wanna do just those 2. Looking good so far. Now I'm gonna go ahead and do 3/8 of an inch holes on the 2 flanges that I made, and that is to attach the top to the bracket and the bracket to the wall. I'm gonna save that as default because that's what I usually use, 3/8 of an inch hole. So I'm choosing that surface. I'm gonna drop one there, keeping them aligned, and I'm gonna do 2 inches off the back. That's where the wall is gonna be. So those 2 inches will give me enough space to put a range. And here I'm gonna go with 1 inch. And then to that edge, I'm gonna do 3/8 of an inch. So that'll give me enough space to use a range when I'm attaching the top. That is where the top is gonna sit, top surface. Alright, now this is the wall side. I'm gonna go ahead and put the two same holes, 3/8 of an inch. I'm gonna go 2 inches of the bottom and 2 inches of the top. That will be the top where the top surface sits, and this is gonna be 3/8 of an inch. Perfect. That's gonna be used to mount this wall shelf to the wall. Alright, now I'm gonna do the a quarter circle. I will do a cutout. Just as it's showing on the details given by the customer. The diameter of this circle is going to be 20 inches. Alright, perfect. And now I'm gonna notch the corners. The corners tend to be dangerous. It can be sharp. And so what I'm gonna do is round them just enough to so it's not that sharp. I'm gonna do 0.05 inches diameter, which is really small. You wouldn't even notice it's a round edge. But if I leave the edges, the corners without that round corner, it'll be really a hazard for the workers. Now I'm gonna flat that. I'm gonna choosing the surface and the direction of the grain. That's that. Perfect. And that's it. That is the bracket. So now I have the top surface and the left bracket. I'm gonna go ahead and do the right bracket. The process is gonna be the same. I'm gonna go to my library and choose a template. It's gonna be stainless steel number 4, 16 gauge, and this bracket looks the same, but it's just built opposite. So it's gonna be the name of it is gonna be 7. Start with a 7 because it's a sheet metal. The item number and number 3 because it's the third PSM that I make. PSM is the extension of the file. Sheet metal files have a PSM extension. So now I'm gonna do the counter flange. Choose the top plane, and I'm gonna make a collinear with that bracket sketch. Okay, the thickness goes into the inside of the sketch. I can choose the direction of the thickness of the material. So it's gonna be 12 inches. And now I'm gonna go ahead and choose the flange on top and this in the back. I'm gonna fast it forward so to make the video a little bit shorter. Alright folks, so that will be it for the right bracket as the design that we were looking for. And next up, we're gonna do all the documentation to process and fabricate this baby. Alright, so thank you very much for giving me the opportunity to be here and for your time. And see you next time.